Multiplying binomials. In the last video, we saw where we were distributing something like this, and you distributed to each term, and so you got 5x plus 15. In this video, this is multiplying here, so in this video we're going to multiply, same idea, except instead of just having a monomial out here times a binomial, we're going to have a binomial times a binomial. So something like this. And it's really easy, you just have to sort of distribute twice. Distribute this x times x, which is x squared, x times 3, which is 3x, 2 times x, which is 2x, and 2 times 3, which is 6. So you distributed the x twice, distributed the 2 twice. Oftentimes you'll hear this referred to as the FOIL method. I'm going to tell you because you might hear it in the future, or you might hear it in another class. So FOIL, meaning first thing I did, I multiplied the first two terms together in the parentheses. The first term in here times the first term in here. So that's F for first. Then the O is the outer two on the outside. So this one and this one. I is inner two, which is the inside two. And then last is the ones at the end of the parentheses. So this stands for first, outer, inner, last. You don't need to know that. It's often referred to as the FOIL method, but you're just distributing each of these two terms. So that's all this is, a distributive method. What ends up happening when you have a binomial times a binomial like this is these two middle terms are like terms, so they can be combined into one term, and you end up with x squared plus 5x plus 6. Okay, let me just do a couple more examples. The only difference in these examples is I want to show you what happens when these are not both positive. So let's make them first both negative. So x minus 3, x minus 4. X times x is x squared. X times negative 4, negative 4x. X times negative 3, negative 3x. And negative 3 times negative 4 is positive 12. And when I combine these two, a negative 4 and a negative 3, I get negative 7x plus 12. Okay, so I'm combining these two. Here when I combined them, I added them together and got 5. Here I added them together and got negative 7. If one of them had been positive and one of them was negative, when I combined them I would have actually been subtracting. So I guess I'll do one of those as well. So x plus 5, x minus 2. When I multiply the first two, I get x squared. The last two, I get negative 2x. These two, I get 5x. And these two, I get negative 10. And when I combine these, 5x minus 2x, I get 3x. So I'm actually subtracting because they're different signs. Minus 10. Okay, and that's called multiplying binomials. Notice in these first three examples, I use just x's here, or 1x on all of these. That's not always the case, of course. You could have something like 3x plus 1 times 2x minus 5. And that just makes it so that this first term doesn't end up being x squared, because you're not doing x times x, x times x. Here you're doing 3x times 2x, which is 6x squared. Then you have 3 times negative 5, which is negative 15x. Now I'm distributing the 1. 1 times 2x is 2x, and 1 times negative 5 is negative 5. And then, of course, I can combine these two. Negative 15x and 2x is negative 13x. And now it looks like this is so the final answer is a trinomial, 3 terms. I multiplied a binomial times a binomial, and I got a trinomial. Altogether, these are called polynomials, multiplying polynomials. Okay, so that's a binomial times a binomial.